Today's lesson is going to look at the complex number system. So in order to understand this, I want to explain. Back in elementary school, you believed that all that existed were positive numbers because that is all you knew about. Then fast forward to intermediate school, and all of a sudden you learned that there were negative numbers. That does not mean that negative numbers just suddenly were found to be in existence. It's just you didn't know about them until then. So we're going to use that same idea for today's lesson. We will spend pretty much the entire year in the real number system, except for in this lesson. I do want to show you that there are other number systems out there besides the real number system. And the one we're going to look at today is the complex number system. And it is going to help us to understand why later in the year we have to be specific and say no real solution versus no solution, or all real numbers as being specific on what type it is. So let's go ahead and get started reviewing some things you already know. So the real number system is where we will live for the majority of Algebra 1. Really, Algebra 1 is the real number system. When you get into higher level math courses, you will start to use complex number system with things called imaginary numbers. But today my job is just to show you they exist. We're going to work a little bit with them in this lesson, and then the rest of the year, we're going to live in the real number system, and we will then understand why we need to be specific and not just say no solution, but no real solution. Okay, so what is the real number system? The real number system are all rational and irrational numbers. These should be reviewed. Irrational numbers is any number that cannot be expressed as a fraction. So that would be square roots of non-perfect squares. That would be decimals that never repeat and never terminate, okay? Then we have rational numbers. And rational numbers is any number that can be written as a fraction. That would include the square roots of perfect squares. That would include decimals that repeat. That would include decimals that terminate. And then rational numbers have subgroups inside of them. So inside of the bucket of rational numbers, there are integers. That means no fractions, no decimals, but it has negatives. Inside of integers are whole numbers. That is really just the number 0. Okay, and then inside of whole numbers are natural numbers, and those are our counting numbers. No fractions, no decimals, and they're all positive. So like 1, 2, 3. Whole number adds in a 0, and then integers are all the counting numbers, 0, and then all of the negative versions of the counting numbers, so the opposite of the counting numbers. Then we have this brand new type of number, which is called an imaginary number, okay? And an imaginary number is simply what it states is that up until now, if you try to do the square root of a negative, you would say it doesn't exist. And that is absolutely correct in the real number system. We cannot square root a negative number. But an imaginary number just says the square root of -1 is this lowercase I, which stands for imaginary. And then if we square I, instead of getting a positive number, we get a -1. That is what an imaginary number is. And then a complex number is just a real number plus an imaginary number. So if it's not just real, if it's not just imaginary, if it has both parts, then that is called a complex number. And complex numbers are everything in this graphic. So let's go ahead and start trying to practice some of this. So we're going to look at the problem, and we're going to decide what category would we place this in. So let's start with 4/9. All right, 4/9 is a fraction. So that is going to be a rational number. Let's go ahead and We've got real. We've got rational. We've got integer. We've got whole. We've got natural. We've got irrational. And then we'll have imaginary over there. Okay. The square root of 4/9. Those are both perfect squares. So that would simplify to 2/3, which means it is also going to be rational. So the square root of 4/9 is also going to go in the rational bucket. All right, the cube root of -8 would be -2 times -2 times -2. And so that is going to go in the integers. No fraction, no decimal. The square root of -4. So the square root of -4 is going to go in imaginary. It is 4 times -1. So another way of writing the square root of -4 is 2i. So it is an imaginary. All right. Let's look at the next one. The square root of 12/3. Well, 12 over 3 becomes 4. The square root of 4 is 2. That is a counting number. So it's going to go into natural. -15 divided by 3 is -5. So it's going to go in the integers. The square root of 25 simplifies to 4. The square root of 4 is 2. And then we want the opposite, so that's -2. That is going to also be a integer. 16 and 49 are perfect squares. So that is going to be rational again. So the negative square root of 16 over 49, that's rational. 0 is, by definition, the only whole number that isn't also a natural number. And then we have plain old 5, which is a counting number. 3i is imaginary. 7i minus 2 is just going to go out here. It is only complex, so this is the complex number system. It doesn't go in any smaller bucket. Pi, we're going to go irrational for pi. I need a different color than what we've used. So pi is irrational. The cube root of 64 would be 4, so that's a counting number. Cube root of 64. Negative 3.5 is going to be irrational. Decimal that terminates. Square root of 10 is not a perfect square, so it's going to be irrational. Negative 2 repeating would be 2/9, so it is again going to be rational. And 0.13133 keeps going on. It's not repeating, so that is irrational. All right. Now we're just going to do a couple practice where we're just going to classify everything that it would belong in. So first, I need to simplify. You're always going to simplify before you classify. So they're both perfect squares. Square root of 49 is 7. Square root of 121 is 11. All right, so the smallest bucket that 7/11ths will go in is it is a rational. All rational numbers are real, and real numbers are complex. All right, let's try the next one. I want to find the cube root of 3 minus 30. I want to find the cube root of negative 27. And the cube root of negative 27 is -3. Okay, so now I'm ready to classify. Smallest group that -3 goes in is integer. All integers are rational. All rational numbers are real. All real numbers are complex. All right, let's try the next one. I want to do the square root of -9. The square root of -9 would be 9 times -1, which would be 3i. So there's the simplified version. And that is imaginary, and all imaginary are complex. All right, let's try the next one. Square root of 24 is irrational, but I can simplify that to 4 times 6. So that's 2 radical 6. Then I've got minus. This would be 25 times -1. So that would be 5i. So minus 5i. Part of the number is irrational. Part of the number is imaginary. So the only place we can place that is complex. All right, so that concludes today's lesson over the complex number system.